right, so here's where we're starting. Today our objective is to use the Pythagorean Theorem to solve for a missing side. So everyone's wide awake with headphones out of our ears. Let me see a show of hands. How many of y'all have used Pythagorean Theorem before? Thank you, students, for raising your hands. All right, so since we're using Pythagorean Theorem today, if you have not heard of it or used it or you forgot, you will learn or relearn today. All right, so you're looking at this sheet you grabbed on the way in. This is Pythagorean Theorem warm-up. So let's see what you remember if you've done this before. A and B and C, okay, are part of a triangle, specifically a right triangle. So you got a right triangle, you got an A, you got a B, and you got a C, okay? So A and B are called what? Anyone remember? Not hypotenuse. A and B are the other ones. So think of it, there's two of them. All right? And if you think of like this, and you think of like the stick guy, okay, these are his legs. Okay? So A and B, the two, like you stand on, okay, those are called legs of a right triangle. And C is called a, like we just said, hypotenuse, okay? So C is between the two legs, hypotenuse. And is the blank side. So when I think of the hypotenuse, letter C, everyone needs to know this. It is the longest side, okay? A and B cannot be the longest side. C has to be the longest side. And it's across from what angle? So whenever you have a right triangle, if you drew an arrow across from the right angle, you would always get the hypotenuse. So it's across from the right angle, as you can see right here. Okay. So A and B are legs. C is a hypotenuse. C is the longest side. Okay. You got to know that or you're going to mess up your Pythagorean Theorem. Okay. So if you hadn't heard it before, it's up here at the top. Pythagorean Theorem is A squared plus B squared equals C squared. So that means one of the legs squared plus the other leg squared equals the hypotenuse squared every time. And it only works for what kind of triangle? Right. So we got 4 examples here. Let's try to use this. Now I want everyone to notice, if you've done Pythagorean Theorem before, you probably used your calculator and got a decimal. So if you remember this whole last 3 days, okay, we've been reducing radicals. So the only difference is that our answers are not going to be decimals. They're going to be reduced radicals. We're going to use what we've been learning the last 3 days with Pythagorean Theorem. So when those worlds collide, okay? So look at number 1. Okay, I've got a right triangle. It might help you to label A, B, and C. Now I'm going to say this now, and I'll say it again probably, but A and B, doesn't matter which one's A and B. As long as it's one of the two legs, A can be B, B can be A, those can switch, it doesn't matter. But C is always across from the 90, always the longest side. So if I were you, every time, to help yourself, draw an arrow across from the 90 and put a C there, okay? Now, do we know C here? No. So you can call it X or you can call it C, and it doesn't really matter, as long as it's a variable, okay? And I'm going to set up my equation. So the first time I do this, I'm going to write the whole equation. A squared plus B squared equals C squared, okay? I'm going to let A be 3. I'm going to let B be 4. And then C is X. So let's write it out. 3 squared plus 4 squared equals X squared. Okay? I am going to solve for X. Now, do I know what 3 squared is? And do I know what 4 squared is? I hope you do. If you don't, your calculator can help you out. Okay? 3 squared is 9. 4 squared is 16. And then I'm going to add 9 plus 16. Okay, so 9 plus 16 is 25. Now here's my question. Is 25 the answer? Okay, so I heard no. So notice how it says 25 equals x squared. X is not by itself. So anytime there's a squared on the x, you have one last step. Now we said this 3 days ago. What's the opposite of squaring something? The square root sign. Square is the opposite of square root. Square root is the opposite of square. So whenever I get to this step, I'll do this in a different color. To get rid of that little 2, I'm going to square root, which will cancel out the 2 and the square root sign and leave me with x. And that's what I want. But if I square root the right side, I got to square root the left side. All right? Now let's think. Do we know the square root of 25? Hopefully you do. If you weren't sure, you could do a factor tree and find out. But we actually hopefully know that 5 times 5 is 25. So the square root of 25 is 5. Now I'm done. So sometimes people mess up on Pythagorean Theorem because they don't do the last step. You got to square root. Okay. So number 1, I was missing the hypotenuse. Okay. Now look at number 2. Now I should have left more space here, but I'm missing this side. This side is not 2. That's problem number 2, right? Does everyone see that? The 2 parentheses is not actually on the triangle, right? So put an X there to let yourself know that your leg is missing. Don't fall down. All right, but seriously, the leg is missing. So I'm going to set this up the exact same way. Now, I know you may have been taught if you're missing the leg, you use a different formula. But I like to be consistent and use the same formula. So let's do that. A squared plus b squared equals c squared. Remember, across from the 90 is your c. It has to be that number, okay? So here we go. A squared. I'll pick x for my a, so x squared plus, and my b can be this 6, so 6 squared. Notice that b is a 6. I know they look similar, but they're different. Equals, and then c squared is 8 squared. Cool. And now let's do those squares, okay? 6 squared is what? 6 times 6 is 36. I'm going to bring down x squared plus equal sign. 8 squared, 8 times 8 is 64. Now, look at x is on the left side. There's 2 things I got to get rid of, right? There's a 2 and a 36 that we got to get rid of, right? So, always get rid of the loner first. So when you get in this situation where you have a missing leg, you are going to have to subtract first. So to get rid of that positive 36, I subtract 36. What's 64 minus 36? Okay, not 38. 28, okay? Is 28 my answer? Almost there. I got to get rid of the square sign by using a square root sign. Cancels out the 2, cancels out the square root sign. Now I have x equals. But now I got to do square root of 28. Okay? If I were you, I would rewrite it off to the side because I'm running out of room and I don't want a nasty mess. So I'm going to rewrite this over here. Square root of 28. We're not going to type it in the calculator. We're not going to get a decimal. We are going to use what we learned to do a reduced radical by making a factor tree. So 28 is even. So what goes into it? 2 times what? 14. 14 is even. So 2 times what? 7. Is 7 prime, or can we break it down? Prime, right? So remember, when you break a number down, I like to cross it out. It's gone. And what's my next step? Circle the pairs. So I got a pair of 2. And remember, tragedy, one of them's gone. So let's remember, because we were technically working on this yesterday, and then the last 2 days, last week. What do I put on the outside? What do I put on the inside? So the circled pair or couple goes out to the left, okay? So it's going to be 2, and then the loner 7 stays in on the right, okay? Don't get those mixed up. So my final answer should be 2 square root of 7, not a decimal. Do you see how that works? You have to, I'm telling you, you're going to have to reduce radicals. If ever you read in the instructions reduced radical form, that's when you do this. If you read in the instructions decimal form, well then plug it in the calculator. Have fun, right? So round to whatever it says. Look at number 3. Okay, number 3, across from the 90 is my C. I'm missing C, so I'm going to set up my equation. Now I'm going to skip the first step where I write a squared plus b squared equals c squared, because by now, hopefully we know it, right? So a squared is 4 squared plus b squared is 5 squared equals c squared is x squared. All right, we can skip another step. What's 4 squared? 16. What's 5 squared? 25. Add those up, and you can type that in one step in your calculator, 4 squared plus 5 squared. But what is 16 plus 25? What? 41? You sure? What'd you get? What'd you get? Anyone want to second that? 16 plus 25. In my large first period class. Anyone else want to answer? 16 plus 25. 41. All right. All right. And then what do I do now? Square root on both sides. So x equals, and now I'm going to think about square root of 41. What goes into square root of 41? Now, it's odd, so 2 doesn't go into it. Does 3 go into 41? If you're not sure, go to your calculator, 41 divided by 3, see if you get a whole number, but you don't, okay? You could try 5, but again, it doesn't end in a 0 or a 5. You could try 7, but 7 doesn't go into that. 9 doesn't, or sorry, 11 doesn't go into that. We could try 13, but I don't think that works either. So I believe 41 is a prime number, right? So again, nothing breaks down, so we just write square root 41. Okay? So sometimes you don't got to do the breakdown if it's prime. Let's try 4. Across from the 90 is C. We can call this A and B, put an X on the missing one. So I'm going to do a squared plus b squared, so 5 squared plus x squared equals 13 squared. You've got to use across from the 90 as C. Too many people, okay, the most common mistake on Pythagorean Theorem is people put x always at C, and that's wrong, 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 wrong. Okay, first identify what C is, and that'll tell you what type of problem it is. Are you missing a leg? Are you missing a hypotenuse, right? So let's do the math. 5 squared is 25 plus x squared. 13 squared, anyone know it off the top of their head? 169, very good. All right, and then since 25 is on the side with x squared, I got to get rid of the 25 by subtraction. Minus 25, minus 25. What is 169 minus 25? 144. Okay. So, like before, I want to do the square root. And off to the side here, I'm going to try the square root of 144. Now, real quick, does anybody know what the square root of 144 is? So it is 12, and you might have that memorized. If you don't, and you want to like potentially save yourself some work, you can try to, in your calculator, press square root of 144, and see if it gives you a whole number. As long as it gives you a whole number, that's it. But if it gives you a decimal, you got to actually do the factor tree. So to do this at warp speed, if you were to do this really quick, this is how you would do it. All right, that was fast, right? And you would see you have 3 pairs, and 2 times 3 is 12, and there's no loner. So yes, even if we did the factor tree, we would get 12, okay? So again, there's no loners on that factor tree. It is what it is, okay? So if you flip that over, okay, we're going to do like a word problem. You got to be careful in these word problems. That's why I'm kind of giving you a table where we're going to break down our thinking here, all right? So what is the length of the slide? So if you're looking at the picture, if you don't understand this, this is a pool, okay? And guess what you do to the pool? You slide into the pool. Here's a ladder over here, right? Ladder. So here's the slide. If they want to know the length of the slide, then that must be missing. Put an X there, right? So let's answer this. What's the given information from the pool to the ladder and the length of the ladder? We know 2 lengths, right? Or you can call it the 2 legs. They gave us 2 legs, 10 and 19, right? What am I being asked to solve? For the slide length, right? Or C is what you're looking for, right? The hypotenuse. So if you can identify that in your word problem, then you can solve for that missing side. Okay. I'm going to move it down a little bit. So if I were to redraw this as a, picture, it's a right triangle with, sorry about that, 19 and 10 and X. This is my C, right? So let's do the work in the box that says work. We're going to set it up. A squared plus B squared is C squared. 10 squared plus 19 squared equals X squared. So, if you're writing this down, hold on one second. 10 squared plus 19 squared, calculator's my friend. One step on this. I get 461. Okay. All right. And last step is square root. I'm going to save you a little time. You can try to break that down many different ways, but 461 does not have any pairs if you were to try to break it down. Okay? Not that we're aware of. And some of the more obscure ones you want to try, 461, like you can try 7, you can try 13, okay, you can try all types of weird stuff, but, alright. Now, since we're talking about length of a slide, anytime we're doing word problems, whenever you measure something, you never measure in actual square roots. Okay, that's not a measurement. So in this situation, with an actual word problem, we're going to allow the decimal format, okay? So we're going to do square root of 461, and we're going to round 2 decimal places. So 21.47. Okay, the 1 after the 7 does not round it up. So 21.47 feet. Okay, that was my units of measure. Okay, you can rewrite it down here, and we want to do it in a complete sentence. So the slide is 21.47 feet long. And then we ask ourselves, is it reasonable? Yeah, 21.47 is longer than 10 and 19. And if you remember the triangle inequality theorem, if you add up these two smaller ones, 10 plus 19, is 29 bigger than 21.47? Yeah. That's the triangle inequality theorem that proves that it works out. Okay? So we're going to use that to do an assignment on Pythagorean theorem. Okay? So the front side is going to be like the front side of the notes. The back side will kind of be like the back side. Okay. So you want to try to finish this today if you can, even if you got limited time. And if you finish this in time, you want to make sure you finish yesterday's assignment. I know not everyone turned it in, so you got potentially 2 things to be knocking out. So also remember, if you need to retake the last test we took or the first quiz we took, come see me in tutoring. You may begin working on your assignment.